Hello everyone, welcome back to 30 Days of Solidity. I am Sneha from the Web3 Compass and this is day 22 of 30 Days Building with Solidity. As of now, we have done a lot of stuff, and for people who are still not aware about what this campaign is, it is time that you head over to our day one video. That is where I talk about the campaign in detail, or you head over to web3compass.xyz and go here, check out the challenge calendar. This is day 22. Today we're going to build a decentralized lottery. Again, we will use Chainlink VRF, random number generation, lottery logic, putting it all together, build a fair and random lottery. You will learn how to use external services like Chainlink VRF to generate random numbers. It's like lottery on the blockchain, demonstrating how to use external randomness. And so far, you already have pulled off some pretty cool stuff. You've made contracts that send and receive Ether. You've protected them with modifiers, looked into attacks, how to save yourself from attacks, and even brought a digital art to life with your own NFTs. But then today, we step beyond the walls of our contract. We're tapping into the real world and building a decentralized lottery. This one's provably fair, fully automated, and impossible to rig. And at the heart of it is something really special, a Chainlink VRF, a trusted source of randomness that works on chain. Okay. Now, what's the catch here? Smart contracts are brilliant, but they're also very predictable. They will only ever do what's written in the code and nothing more. That means they can't really generate randomness. And in a lottery, that is kind of a deal breaker, right? Come on, what is a lottery without randomness? So that is where Chainlink VRF comes in. Think of it like this. You call in a trusted referee, hand them a sealed envelope and say, hey, flip a coin, show everyone the result, and then lock it into the blockchain. That's what Chainlink VRF does. It gives you a random number, a cryptographic proof that was generated fairly, and it delivers both directly to your smart contract. This is how we bring trusted randomness into an not so trustful world. And now that you know what's happening behind the scenes, let's get to building. Okay. So we will write a lot of stuff here. Again, a few things. You will need to have Sepolia test tokens. You can go with base Sepolia. That is, comparatively easier to get. And then you would also need link tokens, again, on the testnet network, because we're going to do real deployments here using our MetaMask. So make sure that you have all of that in the faucet ready. Now, Chainlink setup. So before we spin our lottery wheel, we need a way to get true randomness into our contract, and that's where Chainlink VRF comes into play. But to actually use the Chainlink randomness system, we need to talk to it. And in Solidity, that means importing the right library, sort of like plugin in a smart contract version of a walkie-talkie. Let's our lottery actually chat with the Chainlink's Oracle network. And we will have to do something externally as well, which is again creation of a subscription management, which will again be done on Chainlink. So yeah, let's just get started. Okay. I'll create a file here which says DecentralisedLottery.sol. Okay. I will copy this. Okay, close this, come here. We don't need this. We already know what this is about. And yeah, so it's time we get started. Now what we're going to actually import are like two very, very heavy stuff. One would be, let me just copy it. Yep. And then we say contract decentralized lottery. And yeah, we've done the basic stuff. Now, we're doing two imports. One is a VRF consumer base V2 plus, and then there is a VRF V2 plus client. Now, what do they do? So this is a base contract provided by Chainlink. We inherit from it, and in return, we get a special function called fulfill random words that Chainlink automatically calls when the random number is ready. Think of it as a callback slot for the random number. And the second one, which is a VRF V2 plus client, this is more of a helper library that gives us an easy way to structure and format the randomness request that we send to Chainlink. And it lets us configure things like how many random numbers we want, how much gas to use for the callback, which Chainlink job to use via key hash. Now, together, these two pieces are our direct link to randomness on chain. Without them, we wouldn't be able to securely reach out to the outside world. Now, what we will do is, once we're doing the contract declaration, we will do something as contract decentralized lottery is a VRF consumer V2 base plus. Okay. Now, because it's a decentralized lottery and a lottery that lives on chain. Fairness is pretty, obvious. And notice that we are inheriting from the VRF consumer base V2 plus. This is what gives our contract the ability to receive random numbers from Chainlink and use them inside a logic. So from here, we go on to, what we usually do is define our variables, functions, and, get into events and all of that. Now, every lottery system needs rules. And in that case, our lottery, we need to be crystal clear about what phase the contract is in, because different things should be allowed at different times. Are we letting players join? Are we waiting for the winner to be picked? Or are we just chilling between rounds? So that is where this little piece of code will come in, which is something new. We have not talked about it, and it's called enum. Okay. Now, enum is short for enumeration. Let me just write it. Okay. We're saying lottery state. Okay. And then we say open, closed, calculating. Okay, I want all of these in caps. Calculating. Okay, so it is enum is basically Solidity's way of creating a list of named states that a variable can take. In this case, we define 3 states: open, closed, and calculating. So open is when the lottery is live, the player can enter. Closed is obviously that the lottery is inactive, no entries, no picks, just chill. And calculating is where the lottery is currently asking Chainlink for a random number and no one can enter or restart the game until we get the results. Okay. Now we'll do something as, oh, what am I writing? Lottery state public. And then we will say lottery state. Casing. Okay, state. Yeah. So now why is it important is that this lottery state variable that we are declaring is the contract's brain. It helps us manage the flow of the game and enforce the right rules at the right time. For example, we only allow players to enter when lottery state equals to open. We only start a new round if the state is closed. We only pick a winner when the state is calculating. So this prevents a lot of things. People from sneaking in late during winner selection, accidentally starting a new round, repeated randomness requests, and all of that. Okay. Now we'll go with some player tracking variables. So one would be an address, which should be payable because again, they're going to win money. So we're saying public and then players. It's going to be a list. Okay. And then it says address, public, recent, winner, And what else? We would need an entry fee, obviously. Come on. Why are only people supposed to make money? We need to charge an entry fee, right? Okay. So now, player stores, everyone who joins the round, recent winners, remember who won the last round, and entry fees again. Entry fee, right? Now, there would be a Chainlink configuration happening. When we ask Chainlink for a random number, we don't just say, hey, give me something random. We have to be very specific about how we want it. That's where the set of configuration variables would come in, and you will see what's exactly happening there. So we're saying there would be a uint256 public subscription ID. Now, this is what we're going to set externally on the Chainlink's side of things. Then we say there would be a key hash, which identifies which Chainlink Oracle job do you want it. Like, think of, Chainlink having many different jobs. Each one is powered by different oracles with different configurations, some faster, some decentralized. Then how do we figure out? So that is where key hash comes into the play. uint32 is, okay. Oh my God. Back gas limit, and we're setting it as 3, 4, 5. Great. Okay. So now what are we doing here again? That this basically sets a gas budget for Chainlink. When it calls your contract back with the result, Chainlink has to invoke your fulfill random words function to deliver that random number. And just like any other transaction, it would also need gas. So this number tells Chainlink, hey, you're allowed to use up to X gas when fulfilling the request. Too low, your function might fail. Too high, you're wasting gas. So you want to find a nice middle ground, which is like, 10x, is usually a good safe default for simple logic like winner selection, right? And then we're going with uint32 public request confirmations. We're setting it to 3, and then we say, hey, uint32 public num words equals to 1, and we're saying uint256 public, and there's a latest request ID. Okay. Now, any guesses on what this could be? What are these variables actually for, right? So, okay, request confirmation sets how many block confirmation Chainlink waits before generating your random number. Why? Because the more confirmations you wait for, the harder it becomes to manipulate the result, even by miners. It adds security, even though it's a slight delay. And value like 3 is like a solid balance between speed and security. Then when you come to num words, this tells Chainlink how many random words you want in one request. So we're just picking one winner, so just one is enough, right? But if you're doing something like shuffling a list, selecting multiple winners, or generating NFT trades, you could ask for more. Now, the latest request ID is every time you make a randomness request, Chainlink gives you a request ID. We store it here mainly for tracking purposes. For example, in front end, or if you wanted to verify responses, you can think of it like a ticket number to your randomness order. Okay. Now it's the most fun part, which is writing the constructor. So before we let anyone enter the lottery, we need to set the table. Just like how you would prepare for a real world lottery, printing tickets, locking the prize pool, and setting entry prices, we need to initialize our smart contract with the right setup. And that's what constructor is for. And we love constructors, isn't it? So we're saying constructor, and now everything that we have declared in terms of, important stuff, we're saying there will be an address, a VRF coordinator. Okay, this will again happen when you generate the subscription on the Chainlink side. Then there will be uint256. There will be a subscription ID. That is what we're going to set up, right? Then there would be bytes 32. There would be a key hash, which we have already talked about. Then there would be uint 256 and entry fee. So these are the parameters that we're looking at. Okay. Now we have given VRF consumer V2. No. What was it again? Base V2 plus. I don't know why does AI not suggest things here, like instead of me typing it. Base V2 plus. Now they have here, you have to give the VRF coordinator, and then you will do just the simple subscription ID, key hash is key hash, entry fee is entry fee. That's it. And then, okay, let's just remove it. Okay, here you're also going to set the lottery state to a default, which is lottery state a dot closed. Okay, now you know why this default state, right? Because the constructor, again, it is deployed only once when the contract is first, deployed. So these initial conditions will basically set your table up. Okay. Just a quick rundown through the parameters that we've been talking about. VRF coordinator, address of the Chainlink VRF coordinator on the blockchain that you're deploying to. It will act as the middleman that receives randomness request and returns the result. Subscription ID, we know this is your Chainlink subscription ID used for like paying for the VRF requests. Key hash defines which randomness job Chainlink should use. We've already talked about it. And entry fee is how much ETH or way a player must pay to join each round of the lottery. Now, inside the body of the constructor, we've already talked about. We don't really need to, get on that front. Okay, now it's time to enter the lottery step right up. Okay, so now we'll write these functions which will basically put our lottery to progress. And the first one would be function enter. And this will be function enter. Now this will be a payable function because people are paying to, enter the entire thing. And then what it says is, obviously you will check conditions like, hey, is the lottery state open or closed, right? So you say, okay, lottery state a dot open. If it is open, great. Otherwise you say lottery not open. Okay, great. Now other thing is require the message dot value has to be greater than or equal to the entry fee. Otherwise it says insufficient entry fee. Fair enough. Then what you do is push the players, whoever has entered in that list, and make sure that the message dot sender is set to like payable, because come on, we're taking money here, right? So all the conditions are checked, players are pushed in. So, and we're wrapping again message.sender in payable because we're planning to potentially send ETH back to this address later if they win. So we need to mark it as payable in order to transfer funds. Again, it could be anybody, any random person who is entering the lottery, but we have to make sure that whatever player we are adding to the list is marked as payable. Okay. So now we will let the raffle begin. Okay, so we're saying function start a lottery, right? And we're saying, okay, this can only be done by the owner. Okay, and we're saying, hey, can we just quickly check the same thing, which says lottery state is equals to lottery state dot close, because come on, you have to make sure that you start lottery and then the state is closed. Otherwise you say can't start lottery, right? Fair enough condition to check, right? And then we say we have to do one thing, which is lottery state and then lottery state dot open. Yeah, that's all you have to do. Just set the entire thing to open, right? One button, one boss, very cute little function that we have written here. Now we will do an end lottery. Okay, this looks good. Fine. And again, all these red lines will occur till we are done with the implementation. Because again, otherwise the AI predicts or Remix predicts that this contract should have been abstract. Okay. So now we're saying function end lottery. And again, this will be external only owner. Okay. And we're saying require lottery state. Again, fair enough condition. What will it be? Now you have to do end lottery. So we have to check if lottery.state is open. Okay. Yes. Great. Otherwise, can't end a lottery. Why? Because come on, it's not open. How are we supposed to end it, right? And then once we open it, once we end it, all we have to do is update the state to what? Calculating. Obviously. Come on. Very smart. Okay. Now, another thing which happens here is where we start using the VRF v2 plus client. And now this is basically where the real magic will happen and you start building the request. So we're basically going to craft a randomness request to send to the Chainlink, and I'll show you how we write it. So we're saying VRF plus client, and then not like this, we're saying request dot, not random, not like this. Okay, I'll just remove the entire thing. Okay, so we're saying VRF v2 plus client dot random words request. Okay, and then we're saying we're creating an instance here. So we're saying rec. Okay, and then we say VRF v2 plus client, right? Dot random. Come on. Random words request. Okay, now this is where we give like a few parameters and we say key hash, again is key hash. Okay, comma sub ID. Okay, we've already used the underscore segment. So we say sub ID is subscription ID. Now, I don't want to make such mistakes. You just don't know where the spaces would matter. So, yeah. Then we say request confirmations. Now, it's more like a constant that we have declared, right? Then we're saying num words is, again, num words, comma, callback gas limit is callback gas limit, again repetition. Okay, and then we're saying if there are extra arguments, like write it like this, extra args, we say VRF v2 plus client, and we're changing those args to bytes, right? And then we're giving two things here. Come on, I just need to copy this. Crazy, it's just via v2 dot client, dot extra args v1, and then we say native payment equals to true. I know, very complicated stuff. I know, and we have to make sure we this one. Okay, now what did we do? So with the parameters that we've used here, you know that we're talking about which randomness job to use, who's paying a subscription ID, how many confirmations to wait for, how much gas to use when it responds, and how many random numbers we want. Okay. And then we declare something as latest request ID that we've already done. And we're saying, hey, VRF coordinator. So this is where we actually send the request to Chainlink VRF through this function, random words request. Right? So at this point, our job is done and the contract waits for Chainlink to respond with a random number. And here's the cool part. We don't just call the next function manually. Once Chainlink receives our request and does its cryptographic magic, it sends the result directly back to our contract by calling this another function that we are going to write. Okay. So it says function fulfill a random words, okay, and it is taking uint 256 and then uint 256, basically a list, and then we're saying call data and random words, and this has to be an internal function, and then we override it and we are saying, hey, now we need to perform some safety checks here, right? So we're saying, let's get started. Require, obviously, lottery state equals to lottery state dot calculating, okay? If yes, great. Otherwise, not ready to pick winner. Come on, just ignore my caps and lowercase mixing, okay? And then once we're done with checking the condition, it is time we pick the winner index. So we are saying uint 256 winner index. Now whatever comes with a random words at 0 by players dot left. Okay, so we will use the random number provided by Chainlink and apply the modulo operator to make sure that it maps to one of the player indexes. Let's say we've 5 players and Chainlink gives some number as 48234093 blah blah blah. So we divide it by 5 and then do a modulo and then it comes as 3, right? So the winner index here becomes 3. So the 4th player in the list will win. Okay, now you know why 4th, right? Because it starts at 0. So then we're saying recent winner is equals to winner. Okay, and resetting it for the next round, we're saying, hey, players new address payable. So we clear the players list and close the lottery, resetting the system so the owner can start a fresh round whenever they're ready, right? So we're setting the lottery state as lottery state dot closed. Yeah, great. Now, this is where even the price sending will happen. So we will say, hey, goal success, okay? And what we will do is whosoever is our winner, we do a call, send the value, address, this dot balance. Come on, this line is definitely something that you're aware of. And then the encoding section remains empty. And then we check through require if success was given out. Otherwise, failed to send ETH to winner. Okay, great. So finally, we send all the ETH stored in the contract to the lucky winner. If the transfer fails for some reason, we revert to avoid any inconsistencies. Now, to be clear, we manually call NLottery to send the randomness request, but we don't call fulfill random words ourselves because Chainlink does that for us automatically when it returns the random number. Now, that's how the that's the beauty of how oracles interact with smart contracts, event-driven programming at its finest. Now, we have to quickly write a utility function. We're saying get players, again, external view returns, and then that has to be a list, right? So we're saying address, payable, memory, and what? Return players. Oh, this was internal. Come on. Oh, players.length. Oh, we did not declare the winner. How is that possible? Oh, yeah. So, come on, guys. So we had to do this. We had to make the address payable winner, and then we say players, and then winner index. That's it. Okay, great. I don't know why this is coming. Let me just quickly. Okay, so we made a few mistakes here because this is, declared as a zero. I mean, not declared as a zero, it's declared as an array. This is what we're going to do because it says contract or array type expected, and this generally generates a new, new contracts or arrays, right? So that is the fix here. We also, so here request confirmations. Okay, this is fine. We were expecting a UN32. Great. So now these should work. Okay, great. Now when we come to deploy section, before that, this is, you can just go to Google and say VRF create subscription, sort of like this. And then you can give your email address, project name, and then you can go to create subscription. Now, you will get a MetaMask pop-up like this. You have to basically spend a few, base thing, receive confirmation, close. Now, once you've created that, you will get something like this. There would be an ID, there would be a VRF coordinator, there would be a key hash, and you have to also have some Chainlink tokens as testnet balance, okay? So while you compile it, okay, you have to make sure that you change the remix environment to injected provider MetaMask again. We can just cancel this one. It's fine. I am right now on this contract. So once I change it to injected provider, now what happens when I go to deploy, I have to give the VRF coordinator. I have to give the subscription ID. I have to give the key hash. I have to give an entry fee. So I'll just go quickly copy VRF coordinator, paste it here. Make sure that you create the subscription. This is the ID. So I will click on it. Here's the ID, right? So I will paste the subscription ID. Then I need the key hash. I will close this, come back here. This is the dashboard that you're going to see. And then I will just put 5,000 as entry fee. And later we're going to give the value as a way when we are providing as entry fee or whatsoever. So now you do a transact. And you have to remember that this time we have the environment as MetaMask. So everything would come as a transaction. So let's just confirm it. Now contract deployment here is pending. Now once this is confirmed, you can see it, with the transaction here that it's done. Now let's just scroll here, come to decentralized lottery, and, this is what we have. Okay. Now I am the owner here. I have another account through which I am going to enter the lottery, because right now if you do get players, it's empty, right? And then the player section is empty. The subscription ID you can get, VRF coordinator, request confirmations, you need 3. Recent winner would be a 0 address. Who's the owner? It's me. Numbers, how much won. So this is again, right now lottery status 1, which is again, I think open. No, closed. Yeah. And then latest request ID, it's 0, key hash. So it's more like, what we've already declared. So I will quickly come with this account, like change the account, because apart from owner, you should have a player. And I will enter 5,000 away as message.value, because there was a condition here that in order to enter the lottery, the message.value has to be greater than or equals to the entry fee. And then I will, enter. And it says gas estimation. We start the lottery again. Now I am on the, let me be on the owner account and just start lottery. What is the gas estimation here? Let me just increase it. 3, 4, 5, 6. Oh, shit. Oh. Yeah, keep it back to like 5,000. We're not deploying again, but yeah. So I am on the main account. Let me just start lottery. Both of them are pending. Okay, I don't know why was that failing, so I'll just increase. I mean, it was taking a lot of time, so I'm just redeploying it. Okay. Creation of decentralized lottery pending. Okay, so that was a remix issue. If the transactions are not happening, just cancel it, reload the remix and all of that. So where were we? So I have also increased the entry fee. So now I go to another account, and there I will just, before that, let me just, okay. So the demo is not working as we hoped it to be right now. I tried doing the entire thing again because some of the functions were again not loading, a gas estimation failure and all of that. And now the smart contract is also not being deployed. So this demo is not a very complicated one. All you have to do is deploy using one account, which would be the owner account, and then you can have 2-3 multiple test accounts with certain test tokens in it, and then you call start lottery, which is supposed to be done by only owner, and then anyone can enter the lottery by paying the entry fee. Okay, so you take all of those test accounts and you enter the lottery, and then when ready, call the end lottery. Again, this is supposed to be done by only owner. I would have showed it to you just like I did in the past 21 videos, but I'm so sorry that this is not working and it's pretty late for us here. So yeah, but we're happy to help. Hop on our Telegram. And yeah, back to what I was saying is that the owner can call the end lottery to request randomness, and now Chainlink will automatically fulfill random words. And then if you check the recent winner, you will see that one of these accounts have won, right? And now if you call get players, which I'd already shown in one part, then you get who were the players of, the current round of lottery. Yeah. So I think that's it for day 22. Yeah, 22. We're so sorry that the demo didn't work. We will try to share it in the group once we have this, together. And in this day, you didn't just build a lottery contract. You've taken like a big first step in, the smart contract interaction, because you're using Chainlink VRF and all of that. Now, You've understood how you're using or how you can declare a stateful contract using enum. That is something new that we have done. And obviously you already know how to handle ETH safely and, build contracts that execute external events. So this was your second taste of off-chain to on-chain magic, where your smart contract doesn't just live in isolation, but actually talks to the outside world. So you can take this concept and build a lot of things, blockchain games with random loot drops, dice rolls, card games, turn-based mechanics, NFT minting with randomized rates, mystery boxes and raffles, and way more. So yeah, that's pretty much it for day 2020. Right, 2022, day 22, and I will see you on day 23. Till then, keep building. And for any questions at all, please hop on our Telegram. You can find the link in the description. You can find the link on the website. You can text me and say to happy to help anytime. Bye guys.